Here we have a problem on evaluating limits. Okay, in the given limit, the limit we have for x is infinity. So whenever infinity has a limit for the variable, in our first step what we need to do is, let's consider the expression we have inside the square root in numerator. So what is the degree of the variable x? That means the largest exponent of the variable x. So that is 4. So what I need to do is I have to factor this x to the fourth power from the expression inside the square root. Okay, let me do it. Limit x tends to infinity. So inside the square root, I'm going to factor x to the fourth power out from the expression. Okay, if I factor x to the fourth power out, so what do I have left to the first term and second term? So to know that, I have to divide the first term 9 times x to the fourth power by the one I factor, that is x to the fourth power. When I do so, this x to the fourth power, x to the fourth power will cancel out. I am getting 9. So when I factor x to the fourth power out in the first term, so I have only 9 left positive. So what I have left in the second term? To know that, I have to divide the second term 1 by the one I factor out, that is x to the fourth power, then I'm getting 1 over x to the fourth power. So even if I distribute this x to the fourth power to this 9, to this 1 over x to the fourth power, I'll be getting the original stuff. Okay, now look at the degree of the denominator, that is the largest exponent of the variable x. So that is 2. So I have to factor x square out from the denominator. So if I factor x square out from the expression in the denominator, so what I have left is the first term. So to know that, I have to divide the first term by the one I factored, that is x square over x square, it becomes 1, negative. So if I factor x square out from this 3x, what I have left? So for that, I have to divide this 3x by the one I factored, that is x square. When I divide 3x square by, 3x by x square, it will just become 3 over x. So when I factor x square out from this 3x, I have 3 over x positive. So to know what I've left in the third term, I just have to divide the third term 5 by the one I factored, that is I'm getting 5 over x square. Okay, now I've factored the expression inside the square root in numerator, and also I've factored x to the fourth power from the expression inside the square root in numerator, and I've factored x square from the expression in the denominator. Okay, in my next step, limit x tends to infinity. Okay, here the two terms x to the fourth power and this one are multiplied. So if I take square root for x to the fourth power, it will come out as x square, and then inside the square root we have 9 positive 1 over x to the fourth power over x square times 1 negative 3 over x positive 5 over x square. Okay, so this x square will cancel out. I'm getting a limit x tends to infinity, square root of 9 positive 1 over x to the fourth power over 1 negative 3 over x positive 5 over x square. Okay, so that's all the simplification we can do. Now what we can do is we can plug in the limit for x, that is we can plug in infinity for x into the function. So 9 positive 1 over, if I plug in infinity for x over here, I'll be getting infinity to the fourth power. So whatever exponent I take for infinity, it is still infinity. So instead of writing infinity fourth power, we can write 1 over infinity, 1 negative 3 over, if I plug in infinity for this x, 3 over infinity, positive 5 over, we have infinity square. Infinity square is still equal to infinity. So we get 5 over infinity. Okay, whenever I divide a non-zero number by infinity, it will result 0 because I divide 1 by a very large value. So when I divide 1 by a very large value, the result will be too small, that is 0. So then we get square root of 9 positive 0, 1 negative. Here I divide a non-zero number 3 by infinity, so it results 0, and the same thing for this one also 0. Okay, so we get square root of 9 positive 0 is square root of 9, and here so this is 0, this is 0, so we get 1. So square root of 9 is just 3, and 3 divided by 1 is still 3. So the evaluation of the given limit is 3.